Welcome to Star Chat, the podcast where we explore the wonders of the universe and all its secrets. I'm your host, Carl, and I'm excited to share some fascinating space news with you today. We have a couple of amazing stories to dive into, but first, let's talk about a recent discovery made by NASA's James Webb Space Telescope. The telescope has found evidence of a crystal-spewing protostar, which is a young, actively forming star that's surrounded by a disk of gas and dust. This protostar, called EC53, is located in the Serpens Nebula, and it's giving us some valuable insights into how crystals are formed in space. But that's not all. We also have another story about a dark matter map created using data from the James Webb Space Telescope and the Hubble Space Telescope. The map shows the distribution of dark matter in a region of space, and it's revealing some new clumps of dark matter that weren't visible before. This is a big deal because dark matter is still a bit of a mystery to us, and any new information we can gather about it helps us better understand the universe. And if that's not enough, we also have a story about a strange object in space that's emitting a powerful signal. But we'll get to that later. First, let's take a closer look at this crystal-spewing protostar and what it can tell us about the formation of our solar system. The James Webb Space Telescope has been able to detect crystalline silicates in the disk surrounding EC53, which is a big deal because these crystals require intense heat to form. This suggests that the inner part of the disk is hot enough to forge these crystals, and then they're being carried to the outer edges of the disk by a strong outflow. This has implications for our own solar system, because comets in the Kuiper Belt and Oort cloud contain crystalline silicates, despite being in extremely cold environments. It's possible that these crystals were formed in a similar way to those around EC53, and then carried to the outer edges of our solar system by a strong outflow. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. As we continue to explore the wonders of the universe, I'd like to take you on a journey to the forefront of gravitational wave detection. You may recall that gravitational waves are ripples in the fabric of space-time produced by massive cosmic events such as black hole mergers. Today, we're going to talk about the LISA mission, or Laser Interferometer Space Antenna, which is a collaborative effort between NASA and the European Space Agency. Imagine a triangular formation of 3 spacecraft, each connected by infrared lasers, floating in space, waiting to detect these minute distortions in the fabric of space-time. The scale of this endeavor is truly mind-boggling. Each arm of the triangle will stretch 1.6 million miles, or 2.5 million kilometers. To put that into perspective, the distance between the Earth and the Moon is about 239,000 miles, so we're talking about a formation that's roughly 6 times larger than that. The LISA mission is designed to detect gravitational waves that are beyond the reach of ground-based facilities. By using lasers to measure the minute changes in the separation of free-floating cubes inside each spacecraft, scientists will be able to detect waves generated by massive black hole mergers as well as other cosmic events. The data collected by LISA will provide unprecedented insights into the universe, allowing us to learn more about the physical properties of these events and their distances from us. The technological innovations required to make this mission a success are equally impressive. The lasers must be finely tuned to make precise measurements, to within a trillionth of a meter or a picometer. That's smaller than a helium atom. NASA's contributions to the mission include the development of telescopes, charge management devices, and the framework for processing the data generated by LISA. As we look to the future, the LISA mission is slated to launch in the mid-2030s, and it promises to revolutionize our understanding of the universe. By exploring cosmic signals beyond light, we'll gain a deeper appreciation for the complexities of space-time and the mysteries that lie within. Welcome back to Star Chat. As we wrap up today's show, I want to take a moment to reflect on some exciting news from NASA that could potentially change the game for deep space missions. You see, NASA has just completed a cold flow test campaign of their first flight reactor engineering development unit since the 1960s, and this is a huge milestone in advancing nuclear propulsion capabilities. This technology has the potential to unlock new frontiers in missions to the Moon, Mars, and beyond by providing faster travel times and more endurance. The tests, which were conducted at NASA's Marshall Space Flight Center in Huntsville, Alabama, included over 100 tests on the Engineering Development Unit and provided critical information for the design of the flight instrumentation and control system. But what does this mean for space travel? Well, with nuclear propulsion, we could see increased science payload capacity, higher power for instrumentation and communication, and even more complex deep space missions becoming possible. It's an exciting time for space exploration, and NASA is at the forefront of it all. As Greg Stover, acting Associate Administrator of NASA's Space Technology Mission Directorate, said, "Nuclear propulsion has multiple benefits, including speed and endurance, that could enable complex deep space missions. By shortening travel times and expanding mission capabilities, this technology will lay the foundation to explore farther into our solar system than ever before." That's all for today's Star Chat. Remember to like, share, and subscribe. And until next time, remember to keep looking up at the stars.